Acid and base reactions. An acid-base reaction is one in which hydrogen ion H+ is transferred from one chemical species to another. The acid is the substance that will dissolve in water to yield hydronium ions, or to donate those protons. Example, hydrochloric acid is a strong acid. As we described previously, we can see how when Cl moves from this side of the equation to this side, it donated or lost a hydrogen. But when it donated this hydrogen, the hydrogen was accepted by this guy over here, the water. Because what happened with water? It became H3O. And H3O has one more hydrogen than H2O. So what actually happens in solution is when HCl is added to the water, the hydrogen ions dissociate and then combine with water molecules. So when those hydrogen ions float in solution, they're going to combine with the water to produce H3O. When the chloride ions dissociate, they're going to be surrounded by those particles. So HCl donates the hydrogen ions to solution, and the water here, H2O, is going to accept those hydrogens, and that's why we see this additional hydrogen over here. From previously, we know that this is an acid because it donated or lost a hydrogen, and we know that this is our base because it gained a hydrogen when it moved to the opposite side of the reaction. Virtually every hydrochloric acid molecule that dissolves in water will undergo this reaction. Acids that completely react in this fashion are called strong acids. And this is an example of several different strong acids. But a far greater number of compounds behave as weak acids. They'll only partially react with water. A large majority of dissolved molecules remain in their original form, and only a relatively small amount of hydronium ions are generated. An example of a weak acid is acetic acid. Only about 1% of acetic acid molecules are present in the ionized form. The use of a double arrow in the equation denotes the partial reaction aspects of this process. This is also known as just an acid-base reaction. Some reactions with acid. Acid reacts with metals to create salts and hydrogen gas. Acid can react with bases in a neutralization reaction to produce a salt and water. Acids can react with metal oxides and react with metal carbonate. A base is a substance that will dissolve in water to yield hydroxide ions, or OH. The most common bases are ionic compounds composed of alkali or alkaline earth metal cations, groups 1 and 2, combined with the hydroxide ion. So examples of bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, and barium hydroxide. These bases, along with other hydroxides, completely dissociate in water and are considered strong bases. The dissociation process is essentially complete when NaOH is dissolved in water. This process is a dissociation, physical process, and not an acid-base reaction. Some compounds produce hydroxide ions when dissolved by chemically reacting with water molecules. In all cases, these compounds react only partially and are classified as weak bases. An example is ammonia. This is an acid-base reaction. Hydrogen is transferred from water molecules to ammonia molecules. A neutralization reaction takes place between citric acid and lemons or acetic acid and vinegar, and the bases in the flesh of fish. So in a neutralization reaction, you have an acid combine with a base, and their properties cancel each other out to create salt, water, and heat. Acid-base reactions are detected by an increase in temperature. So this is an example of an acid-base reaction. So H2SO4 combining with BaOH2, this is a double displacement reaction. So one of the hydrogens, the hydrogen is going to knock out the barium. The barium is going to combine with the sulfate, and then you're going to have the H combine with the OH to create water. So what salt forms from the reaction of magnesium hydroxide, Mg2 plus OH minus, and sulfuric acid? Sulfuric acid is talking about H and SO4, the sulfate polyatomic ion, because we have that IC ending. So the H is going to combine with the OH to create H2O, and the Mg is going to combine with the SO4. Now because we have the +2 and the -2, those are going to cancel each other out. So MgSO4 is our final answer. So I'm going to let you try this one. So go ahead and pause the video, try to figure this one out, and then we'll unpause and go through it. So what salt forms from the reaction of aluminum oxide and hydrobromic acid? So the H is going to combine with the O to create H2O, and aluminum is going to combine with bromide, and when we flip down the charges, it becomes AlBr3. Okay, so now you are supposed to figure out what the products are, then balance the chemical equation, then name the products. So the first one, we have sulfuric acid and potassium hydroxide. The second one, we have phosphoric acid and lithium hydroxide. And the third one, we have carbonic acid and magnesium hydroxide. So go ahead and pause the video, and you are going to write the products, balance the equation, and then name what the products are. Okay, so we are going to do a double displacement where we're going to combine the hydrogen with the OH to produce water. And we're going to combine the potassium with the sulfate to produce potassium sulfate. So when we combine potassium, which has a +1 charge, with sulfate, with SO4, which has a 2- charge, and we flip down the charges, this becomes K. Let's get rid of that. K2SO4. So to write this more neatly, K2SO4 plus H2O. Now we have to balance this. So there's 2 hydrogen on this side, 2 hydrogen on this side. The sulfate family is balanced as a family, so we have 1 sulfate on that side, 1 sulfate on that side. But with the hydrogens, we actually have 3 hydrogens on this side, so we'll come back to the hydrogen later. The sulfate, we have 1 and 1. The potassium, we have 1 potassium but 2 potassiums. So we're going to have to put the number 2 in front of here. So now we have 2 potassium, 2 potassium. We still have 1 sulfate, 1 sulfate. And now we have 2 oxygen, and we only have 1 oxygen over here. So we're going to put a number 2 here. So now we have 2 plus 2 is 4 hydrogen, and 2 times 2 is 4 hydrogen. So if we go ahead and start over just to confirm everything, we have 4 hydrogen total on the left side. We have 4 hydrogen total on the right. We have 1 sulfate family, 1 sulfate family. We have 2 potassium, and we have 2 oxygen on each side. So it's balanced. Now to name these, this is potassium sulfate. And this is water, but in order to name it correctly, dihydrogen monoxide. Okay, going to this next one. So the hydrogen's going to combine with the water, or sorry, with the hydroxide to make water. So we're going to have H2O for sure. And then the lithium is going to combine with the phosphate. When we combine the lithium with the phosphate, we have to consider charges. So Li has a +1, PO4 has a 3-. So when we flip down our charges, this becomes Li3PO4. So now we're going to go and balance. So on this side, we're going to skip the hydrogens and oxygens, but we are going to balance these as such. Now I am going to erase this just so we can make this more clean. So this became Li3PO4 plus H2O. And we're going to start with our phosphate family. So we have 1 phosphate, 1 phosphate. We have 1 lithium, 3 lithiums. So we're going to put a number 3 here. Now we have 3 oxygen, but we only have 1 oxygen over here. So we're going to put a number 3 over here. Remember, we are not balancing this oxygen and this phosphorus independently. That's why I put the parentheses around it. This is a family, and the family is not going to be separated. So PO4 stays together, PO4 stays together. So we keep those together as a family. So we have 3 lithium, 3 lithium. There's 1 phosphate, 1 phosphate. We have 3 oxygen, 3 oxygen. Now we have to count up the hydrogen. We have 3 plus 3 is 6 hydrogen, and we have 6 hydrogen on this side, so now it's balanced. In order to name this, this is lithium phosphate plus dihydrogen monoxide. Okay, for the last one, again, we're going to combine the H and OH to produce water. And we're going to combine the magnesium and carbonate. Mg has a +2 or a 2+ charge. Carbonate is CO3 2-. So when we flip down, those cancel. This is MgCO3. To balance it, I'm just going to clean this up here. Mg, CO3, plus H2O. We're going to skip the hydrogens for now. So we have one carbonate, one magnesium, one magnesium. We have two oxygen, but only one oxygen. So we're going to put the number 2 here. Now we have 1, 2, 3, 4 hydrogen, and we have 4 hydrogen, and this is balanced. MgCO3 is magnesium carbonate and dihydrogen monoxide. The last topic we're going to touch on is a titration. A titration measures the volume of one reagent that's required to react with the measured mass or volume of another reagent. A titration is used to determine the amount of acid or base present in a sample. An indicator solution is used to signal the endpoint when stoichiometric amounts of acid and base are present. So the indicator solution here looks like it may be a phenol red compound. There's all sorts of different colors that this can change depending on what indicator we use. A burette is used to deliver the titrant into an Erlenmeyer flask. So this is the burette, this is our Erlenmeyer flask, and the titrant is going into the titration. So we will be performing a titration in this class, so this is just giving you a little preview of what a titration looks like.